Welcome to partial fractions with prime quadratic factors. So for our first example, let's go ahead and evaluate the indefinite integral, which is the integral of 3x squared plus 2x minus 1 all over x cubed minus 2x squared plus 4x minus 8. So we wind up with here the denominator we can factor. So let's go ahead and factor the denominator. We have x cubed minus 2x squared plus 4x minus 8. If we go ahead and try factor by grouping, that first group, x cubed minus 2x squared, we can pull out an x squared. We are left with x minus 2. In the second group, plus 4x minus 8, we can pull out a plus 4. We are again left with x minus 2. We have our common factor of x minus 2, which can be pulled out. We have x minus 2 times x squared plus 4. And at this point, we're done. X squared plus 4 is prime and cannot be factored further. So we have our integral of 3x squared plus 2x minus 1 all over x minus 2 times x squared plus 4 dx. At this point, we're going to go ahead and split into partial fractions. So we will run partial fractions. So our integrand, 3x squared plus 2x minus 1 over x minus 2 times x squared plus 4 will be set equal to, we will do a capital A over x minus 2. For the next piece, we will actually do a capital B times x plus capital C over x squared plus 4. So if we have a linear factor, linear denominator, then we can do a constant numerator. Versus if we have a quadratic denominator, then we do a linear numerator. Essentially, the numerator is 1 degree below the denominator. Once again, we'll go ahead and clear the denominators. We wind up getting 3x squared plus 2x minus 1 is equal to a times x squared plus 4 plus bx plus c times x minus 2. Now that x squared plus 4 cannot be made to go to 0 unless you introduce complex numbers. We can make the x minus 2 go to 0. So if we plug in x equals 2, then we'll have bx plus c times 0. And so we get 3 times 2 squared plus 2 times 2 minus 1 is equal to a times 2 squared plus 4 plus bx plus c times 0. That winds up giving us, let's see, 2 squared is 4 times 3 is 12, plus 4 would be 16 minus 1 is 15, is equal to a times 8. And so our a is 15/8. So we have 3x squared plus 2x minus 1 is equal to 15/8 times x squared plus 4 plus bx plus c times x minus 2. At this point, there is no special x to plug in, so you can just pick x's, or we can match coefficients. So I'm going to finish off just matching coefficients. So no more special x's. So I'm going to expand and match coefficients. So we have 3x squared. Oops. We have 3x squared plus 2x minus 1 is equal to 15/8 x squared plus 15/8 times 4 would be 15/2. Then we have plus bx squared minus 2bx plus cx minus 2c. So this is 3x squared plus 2x minus 1 is equal to, we have a 15/8 plus b times x squared. Then we have negative 2b plus c times x. And finally, we have 15/2 minus 2c as our constant. So matching coefficients, we have the 3 in front of the x squared should match that 15/8 plus b squared. Sorry, 15/8 plus b. So we have, therefore, that b should be equal to 9/8. We can match whichever of those other two we want. If we go ahead and match the constant term, we have a negative 1 and a 15/2 minus 2c. So we have negative 1 should be equal to 15/2 minus 2c. That means we have negative 17/2 is equal to negative 2c. And therefore c is equal to 17/4. So this gives us that our original 3x squared plus 2x minus 1 over x minus 2 times x squared plus 4. Let me check the signs on that in a moment. 3x squared plus 2x minus 1. Over x minus 2 times x squared plus 4 is equal to a was 15/8. So we have 15/8 over x minus 2 plus we have 9/8 x plus 17/4 over x squared plus 4. At this point, we can switch back to our integral. So continuing on from here, we have our integral of 3x squared plus 2x minus 1 over x minus 2 times x squared plus 4 dx is equal to 15/8 times the integral of 1 over x minus 2 dx plus, I'm going to write this as two separate ones, 9/8 times the integral of x over x squared plus 4 dx plus 17/4 times the integral of 1 over x squared plus 4 dx. Each of these is one of those special integrals that we knew how to solve. So this becomes 15/8 times the natural log of the absolute value of x. Actually, let's do these three integrals separately quickly. So integral of 1 over x minus 2 dx was just the natural log of the absolute value of x minus 2 plus c. The integral of x over x squared plus 4 dx. If we did u substitution, if we set u equal to that x squared plus 4, that gave us du was 2x dx, or x dx was 1/2 du. This wound up giving us 1/2 times the natural log of the absolute value of x squared plus 4, and then plus c. Our last one, that integral of 1 over x squared plus 4 dx. This was our tan inverse case with a equaling 2. This is 1 over 2 times tan inverse of x over 2 plus c. So putting this all back together, we get that our integral of 3x squared plus 2x minus 1 over x minus 2 times x squared plus 4 dx is equal to the natural log of absolute value of x minus 2. Sorry, we have that coefficient was 15/8 times the natural log of the absolute value of x minus 2. Then we had plus 9/8 times 1/2 times the natural log of x squared plus 4. Then we had plus 17/4 times 1/2 times the natural log of the absolute value of, times tan inverse. So plus 17/4 times 1/2 times tan inverse of x over 2, and then plus c. Let me update my screen quickly. So again, that last part was plus 17/4 times 1/2 times tan inverse of x over 2 plus c. So this is an integral where we had a prime quadratic factor. I have one more example with a prime quadratic factor. I'm going to go ahead and do that in a new video. So in the next video, we will look at the integral of 2x plus 1 over x cubed plus 3x squared plus x minus 5 dx.